Okay, I forgot to hit record on this, but this is useful information. We're going to diagonalize matrices into this conjugated form, PDP inverse, where D stands for the diagonalized eigenvalue matrix. A and B are eigenvalues. P is an eigenvector matrix, and P inverse is literally the inverse of the P matrix. One thing that is important. The eigenvector that goes with A must be in the first column of the eigenvector matrix. Don't swap your eigenvectors and your eigenvalues. So, which eigenvalue is which doesn't matter. But there's an eigenvector that corresponds to eigenvalue 1. So A. That has to be in column 1 of your P matrix. The one that corresponds with B has to be in column 2. You can do this with 3 by 3 and 4 by 4 and any square matrix. For this class, you only have to do 2 by 2. Okay? You, yeah. If 3 by 3 were on the test, I'd make you do it in class. If it's on the test, I'm going to try to make you do it in class. Okay? So, let's do an example of this whole thing. It says, let A be this, and x1 and x2 be two eigenvectors of A. Find the corresponding eigenvalue for each eigenvector. We're just going to start by finding the eigenvalues. And year 2, you'll be doing this with calculus next week. You'll have to find the eigenvalues, use the eigenvalues. You have to put your differential equations into a matrix, find its eigenvalues, use its eigenvalues. So make sure you know how to find eigenvalues. The other stuff I'll teach you that day. So we do this matrix, and we do the determinant equals 0, which is AD minus BC. And this works out to be a quadratic. So I can factor that. So lambda equals 3 or negative 2. Now I need to figure out which one goes with which eigenvector. So I'm just going to go through finding an eigenvector. Pretend that they didn't have them here. So what do? I plug them in. 1 minus 3, 2, 3, 0 minus 3. And I treat that like it's times AB equals 0, 0. So this is -2. That's -3. And I can multiply this row times column, giving me 2a plus, or -2a plus 2b equals 0. What's the simplest values of a and b that work for this? 1 and 1. My other line would give me the same thing, 3a minus 3b equals 0. So this one corresponds to 3.
Well, so in order,
So, and the other you should substitute to.
Now I'm going to substitute -2. That'll give me x2.
wait, so with plugging it back in, what does that show us? What equals? Like.
This is how you find your eigenvectors. So I'm going to do one that's not 1, 1 here. Yeah, but you didn't know which one matched with which eigenvalue.
How does plugging 3 in show us that it matches?
Because I just found that the eigenvector for this is 1, 1.
Gotcha, okay, yep.
Remember that there are infinitely many eigenvectors, because I could also go to 2, 2, 3, 3. You could take any eigenvector and multiply it by any scalar. Could do pi pi for that matter. But well, usually you should just do the simplest one you can. So 1 minus -2, 2, 3, 0 minus -2. Then this is times AB equals 0, 0. They're always times AB equals 0, 0. That becomes 3. This is 2. Yes. That is literally both equations. Now, in both cases, you'll get two equations. They should work with the same thing. If they don't, you made a mistake. So now I pick one of these and go, what solution works? We'll essentially exchange them, except one of these has to be negative, correct? So 2, -3. You could also do -2, 3. Perfectly valid. It does not matter which one you do. You should do simplest whole number ones. No, 2, -3 goes with eigenvector 2, which is -2. It could be -2, 3, though. And that would be just as valid. I multiplied by -1. That's still essentially simplest terms. It will change your inverse slightly, and as long as you do one of the acceptable versions, I don't know what they'd do on the test if you called it 17 -34. Wait, no. If you called it 34, and we'll do an easier one. 16 -24. So where you multiplied by 8. I don't know what they'd do. Be like, what? That's kind of what I think they'd do. Huh, this doesn't line up. So, does that all make sense so far? I'm gonna erase because I want to leave stuff. Actually, no, I'm gonna clear. I'll just rewrite it. Mhm.
Be great. It's not the teacher's, right? It's not.
I don't ever see your test. So those are my corresponding eigenvalues. Now it says P. Notice what they did for P. They just took x1 and x2 and put them in matrix. And it wants me to show that AP equals PD. Okay? So this is going to be my AP side. I'm going to put PD below it. And how do we matrix multiply? Row times column. 1 times 1 plus 2 times 1 is 3. 1 times 2 plus 2 times -3 is -4. 3 times 1 plus 0. Three plus 0. -4. This one's easier because of the zeros. And those match. Matrix multiplying. So it said show that. This is P. D is just literally take my eigenvalues and put them in. It was important though that 3 went as eigenvalue 1. Because 3 matched with eigenvector 1, which is on this side. Year 2 as you're going, oh, this isn't that bad now.
Where?
When P is the 2 eigenvectors.
I was saying that there was a.
They thought it was really bad in year 1. And then when they watched it again, when I went through it with you, they were like, oh, yeah, that's not that bad. Differential equations, that's what's coming next. It might be a little better this year. I might have a better understanding. And there's a lot of resources in Revision Village. Do you guys know how to make a class in Revision Village? I don't have you in a class for me. So I don't know how to give you assignments. I can try to ask Mrs. Mayo if you guys don't know. Because we're going to use Revision Village for instead of the Cognitive exam style review, because they have 0 differential equation questions in Cognitive. I'm like, well, that's not helpful. Revision Village has 35, more than you can do, but they also have videos explaining how to do every one of them. So I need to pick out the questions that you're gonna do.
There's one
But-
big key problem thing.
Depends on the problem. Depends on if it has parts G. There's, some of them are almost like paper 3 problems. And so those are going to take you 20, 25 minutes. Some of them are going to take 5 or 7. I mean, they take 5 minutes if you know what you're doing. They'll take 10 or 12, 10 or 15 if you don't. If you've spent more than 10 or 15, watch the video. If you've struggled with it, like, I'm not getting anywhere. So, so does that make sense, Abby, how we got these matrices? Now it says explain why this is true for when the columns of when they match. Okay, explain why it's true. So the theory behind this, I'm going to go back to if it'll work, was we had this. With x being an eigenvector and the eigenvalue. Okay? So that's the definition. This is the definition of eigenvector and eigenvalue. So a matrix, that's my starting matrix, times an eigenvector equals the eigenvalue times the eigenvector. That make sense? That's the definition. That's where we started. That's how we created these.
Yeah.
Okay. We went through an easier technique to create them than looking at that, but that's essentially how the creation goes from. So why does this work with these matrices?
Equals the.
So what's happening with AP is A times x1 and A times x2 when we put it in a matrix, right? Equals P is eigenvector 1 x1. The other part of P is eigenvector 2 x2. Oops. And that is the definition of eigenvalues and eigenvectors. No, that's not.
No.
It's a scalar times a vector. So it's not a dot product.
I'm just Josh.
But the matrices essentially, because of these zeros in the diagonalized one, and now I'm going to show you how A equals PDP inverse. Watch this. So I need to leave some room. How would I solve for A? Any ideas?
Right divide. No,
Right? You can't, right? Multiply by P inverse? Abby, this makes sense? So the A matrix equals, there's some excitement over actually understanding, and it's clicking.
Understand.
That makes sense? Little matrix algebra. This is linear algebra. Except linear algebra, I don't know what CEI would do. Mr. Klein and a lot of other ones had, a lot of linear algebra classes have to do all kinds of proofs with these. But what I just did is borderline a proof. You just have to set up some conditions. You'd have to make it a little more formal, but that's a proof. Is that really, that wasn't that bad, was it? Like, it's harder when you have to think of it on your own, but these are not that bad of things to prove. You could get proof calculus. Okay, so now we're going to actually go through the whole thing and diagonalize this matrix. So, we must start by finding the eigenvalues. And I would say you should always just go ahead and write this out. Oops. Four minus 4 lambda. That's an ugly lambda. Plus lambda squared minus 36 equals 0. Now I'll put it in a normal quadratic order. 8 and 4. This is why being able to factor helps. Right, and yeah, -4. So now I need to find my eigenvectors. So, do one of them in red. 2 minus 8, -12, -3, 2 minus 8. That's -6. And it's always times AB equals 0, 0. So I've got -6A minus 12B equals 0. I've got -3A minus 6B equals 0. I'm going to call that 1, -2. No, backwards. 2, -1. So I took the bottom because it was smaller, I essentially crossed them and reduced. 6 and 3, and then I'd reduce it to 2 and 1. And one of them's got to be negative. Now we'll do the next eigenvector. 2 minus -4. These are both +6 this time. So 6A minus 12B equals 0. +2, 1 will work for this one.
Negative. Oh, wait, no.
So D matrix. 8, -4. P matrix. 2, -1 went with the 8, and 2, 1 goes with the -4. Now I've got to do the inverse, and then I got to show that it equals A. So inverse, guess we're going to do that over here. AD minus BC. Minus switch A and D, negate B and C. So my front thing, that's 4. The inverse equals 1/4, -1/2 when I multiply the 1/4 through 1/4, 1/2.
Why is P inverse one, why did the matrix change? Wouldn't it be the same matrix?
P inverse?
Well, not P inverse. Yeah, one, negative two, one. Yeah, yeah, sorry, that's what I meant.
So, P inverse.
Oh, we switched that.
You switch. So I just wrote out the inverse matrix. This is not P. It's 1 over determinant times swap A and D, negate B and C.
I forgot that.
I'm gonna start erasing some of the eigenvector work and eigenvalue work. I haven't completed part A yet. Part A would be worth a lot of points. Probably on an exam, that would be parts A. They'd probably ask you to find D and P, and then they'd ask you to put it together, show PDP inverse, and then they'd say, show that it's equal to A. Okay. Or this might just be too easy for an exam. Do you guys have P inverse now? So, the conjugated form of A is 2, -1, 2, 1, 8, 0, 0, -4. Hmm. So I can do matrix multiplication. I can group them however I want, which means I can do D times P inverse first. Anybody know why I'm going to do that? Well, the zeros make it easier. Don't have to. So you can do associative property, right? Which says I can group however I want. Okay. I cannot change the order of those, but I can group them however I want. Okay. So I'm doing that because I want to get rid of the fractions. And that's going to get rid of my fractions.
Wait, so
I'm going to times D by P inverse first instead of P by D. I mean, you'll get the same thing. 8 times 1/4 is 2 plus 0 times 1/4. 8 times -½ is -4. -1. -2. Now I'm going to do P times that multiplied together matrix. 2 times 2 is 4, plus 2 times -1 is 2. 2 times -4 is -8, plus 2 times -2 is -12. 2 times 2 is 4. Oh no, I gotta do bottom line. 2 times -1 is -2, plus 1 times -1 is -3. -1 times 4 is 4, plus 1 times -2 is 2. And that is A. -1 times -4 is +4, plus 1 times -2 is 2. Okay, so now it asks me to write a to the fifth. Here's the beautiful thing about a to the fifth. A to the fifth equals P d to the fifth P inverse. So and d to the fifth is really easy. Because of the zeros, the fifth power, which I suppose, oh, negative 4 to the fifth is a negative. So I don't really need to write the parentheses. I can know it's negative 4 to the fifth, which is the same as 4 to the fifth negated. Now it wants me to actually multiply this out. What's 8 to the fifth?
Probably a gnarly number. Yeah. And then
It's a big number.
32,768.
What's 4 to the fifth?
1,000 people. The negative one row.
Negative 1024. So now I'm going to multiply it by these other ones, which, don't worry, that worked out. I'm going to multiply that by this one first. Okay, I'm going to do the fractions. It'll make smaller numbers. And remember the times zero, all I need is 3278 times 1/4. What's 32,768 divided by 4?
8,000.
8,092? 192. And then by 2, and a negative is going to be 6,384, I think. So I'm just looking at what I did up here. 8 times there. And then now the next row is negative 4. This 1024 divided by 4 is negative 256. And divided by half is negative 512. Now my matrix multiplication isn't as nice. And I need you to use a calculator for this. But notice I could do all of this with a scientific calculator. I could not have done 8 to the fifth would have taken a while. And it wasn't even a 10th or a 20th or a 50th. And
Matrix in it. Why are we multiplying by P and P?
because I want A to the fifth, not D to the fifth. Because no, this is A diagonalized. So this is A, Abby. Now, the beautiful part of when I diagonalize A to the fifth, I only have to take the D to the fifth. Okay? And somebody proved that somewhere. We're going to take their word for it that I don't have to take the P to the fifth and the P inverse to the fifth. Okay? But instead of having to do this, and you guys in graph theory did a matrix to the 50th. No, it was to the 6th on the exam. To the 6th. There's one somewhere in one question where you like take it to the 50th power. And your calculator does it for you. But if you did the sixth one as a huge matrix, you took it to the sixth, the calculator did all the work. Hmm. Next Thursday. So now to multiply, I'm doing row one times column one. Did anybody do that? 15,872. Oh, 33,792 was the 88. 8,000 for, not 88,000. And that is our wonderful A to the fifth matrix. Yes, it would be easier to do it on your calculator. The and if it's on the test and it's numbers, it might ask you to find PDP inverse. I would not multiply A to the fifth out by hand, even if I had it, but it might ask you to show it like this. Um, but you definitely have to be able to find eigenvectors and eigenvalues for other things. Do you guys remember finding them on the calculator? Um, okay, I'll show you. And it's a useful tool. You don't get it on exams, though. I have to shut off a lot. I have to shut off all the advanced vector features. I think I have to shut off a lot of vector. The IB exam. Yeah, it's
Very well.
sorry. Your Inspire is great, and they've decided that it's too good. And I don't agree with them shutting it off, but they do. I would personally be in favor of there's some non-calculator questions. So to do this on the calculator, first thing we're going to do is enter our matrix. Doesn't matter. Was my what? Oh, I'll just go to a scratch pad. Was it 2 negative 12 or 12? We're going, yeah, what was the other one? Negative 3, 2. Okay, that's correct. I'm just going to store it as A so that I don't have to retype it or copy and paste it all the time. Second variable or control variable is stow. Now watch. A to the fifth. That's what we got. Now let's find the eigenvalues. Menu, matrix and vector, advanced. Eigenvalues of A. 8, -4. Same thing for the eigenvectors. The problem, eigenvectors will not give you a nice one.
That's the mid one.
It didn't give it as the D matrix, it just gave you the two eigenvalues. The eigenvectors should come out in the same order. Notice that it's 2, -1, 2, 1. The 8 corresponds with the 2, -1.
So is there a purpose for it to be in that form, I guess? Like, why does the calculator do it like?
I don't know. It'll give you the ratio. It won't give it to you as nice numbers. Turn it into nice numbers. Like, figure out what the ratio between those are. Pretty much, yeah. And you can use this to check. Make sure you know how to do these by hand. Okay? If you wanted the inverse, I would just literally enter the inverse as a matrix. Now that I've gotten simple numbers, I'm entering my P matrix
Why is there a period?
because I accidentally typed a period. I don't think it'll matter though. We're gonna find out. Yeah, it didn't matter. I could store that as P and then inverse it.
Students.
And voila.
Stop the wall.
Okay. That rang a bell that did not go as fast as I thought it would. But you did seem to recall a lot, year two.